Okay, we're going to look at a summary of equations, trig equations so far. So there's a wee bit more to come with this, but probably good to take a pit stop and review what we've done already. Okay, so example 1, let's try this one. 2 sine x plus root 3 is equal to 0. We're looking for solutions that lie between 0 and 360 degrees. Bring that over. 2 sine x equals minus root 3. Sine x equals minus root 3 over 2. Okay, now at that point I'm putting down the cast diagram. Okay, I'm then changing that negative result to a positive result because I know that that's my routine with that one. However, instead of looking in the all in the sine quadrant, I'm going to look instead in tan and cos. So for sine is positive and all in sine, but it's negative. I've changed it to positive. I'm going to look in tan and cos. Okay, x equals sine inverse root 3 over 2. So when sine equal to root 3 over 2, that's one of my exact values, and that is 60 degrees. However, I'm not in the all quadrant, therefore that is not a solution, so I'm going to score it out. I'm, however, in the tan quadrant, and the tan quadrant tells me to do what? It tells me to move on from 180 degrees, so 180 plus the 60 is 240 degrees. Okay, I'm also in the cosine quadrant. The cosine quadrant tells me to move backwards from 360, that's take away, so 360 take away 60 gives me 300 degrees. Okay, let's try an example 2 and bring something else in. Okay, so we've got, let's try this one. 10 cos 3x is equal to 9.6. And we're looking for solutions that lie between 0 and 2 pi. Now the insinuation here is that we need to be on radians. Quick look at that equation. It doesn't look as if it's going to be exact values, so I think at this point we need to be get the calculator in the correct mode, which would be radians mode. Okay, so we've got cos 3x then is equal to 9.6 divided by 10, that's 0.96. Let's get the cast diagram up. Okay, and then it's going to be 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so 3x equals cos inverse 0.96. Okay, and I'm going to be in the all quadrant and the cosine quadrant. Let's make sure that the calculator is on radians mode and put that in. Okay, and that'll give me 0.28 radians. Okay, so that's my all quadrant result. For the cosine quadrant result, it's going to be 2 pi take away 0.28 radians, so that's going to be 6.28 take away 0.28, which is 6 in the dot. Okay, and the other thing that I need to be thinking about here is to adjust my limits. I've got a triple angle, so that means multiplying the limits by 3. Okay, so I've now got 0.28 and 6, and then I know that the cosine function repeats after 2 pi, so I need to add on 2 pi until I exhaust all my solutions. Okay, so that's going to be 2 pi plus 0.28, so that's 6.28 plus 0.28, that's going to be 6.66, and then I'm going to add 6.2 onto this, which is going to be 12.28. Okay, let's get a feel for what 6 pi is, so that's going to be 3.14 times 6, that's about 18.84. Okay, I'll then add on 6.28, that's 2 pi again, onto 6.66. And that is 12.94. And then it's going to be 6.28 onto 12.28. That's 18.56. And then 12.94 onto 6.28. 19.22. Okay, and I've finally got to a point where I'm beyond my upper limit, so I'm going to cross that one out. I'm then going to divide all my answers by 3. Okay, so the first one, 0.28 divided by 3, will give me 0.09. The second one is going to be 2 in the dot. Next one, 2.22. The next one, 12.28 divided by 3 is going to give me 4.1. And then 12.94 divided by 3 is going to give me 4.3. And then finally 18.56 divided by 3 will give me 6.2 radians. Final answer. Okay, now just let's summarise what went on with this one. So I had to deal with the fact that I had a bigger angle here, I had a triple angle, so I multiplied limits by 3, 0 times 3, 0, 2 pi times 3, 6 pi. Okay, brought that down and I'm in the cosine quadrant. Okay, next thing is I needed to make sure that this is a calculator question and it's on radians, so into radians mode. First two results, but then I need to take into account that I'm going up to 6 pi here. So the cosine function repeats after 2 pi, so I had to move 2 pi on from there, 2 pi on from there, and then on again. And then remember that 2 pi is 2 lots of 3.14, 6.28, so that was the result that was added on each time. Then I had to divide through by 3. Okay, let's try an example 3 and another type. We're going to solve 4 sine squared x plus 11 sine x plus 6 is equal to 0. And we're going to solve it correct to decimal places between 0 and 2 pi, so it's radians again. Okay, now my first move is, you can see that that is a quadratic trig equation, so let's liken 4 sine squared x plus 11 sine x plus 6 equals 0. Let's liken that to 4x squared plus 11x plus 6 equals 0. Okay, then it's the National 5 skill dealing with this factorisation process. Two numbers that multiply give 4 and 6, that's 24, and add together give 11. It'll need to be 8 and 3. Okay, so it's bracket plus 8, bracket plus 3, drop my 4x in here, drop my 4x in here. Okay, then take out a common factor of 4, brings me down to x plus 2, bracket 4x plus 3. Okay, then let's bring that back in. Now, really what we've did there is a quick kind of informal substitution of sin x being x. Let's bring that in, so that'll be 4 sin x plus 2, close the bracket. Or rather just, it's not 4 is it, it's just x, so it's just sin x plus 2, bracket 4 sin x plus 3 equals 0. Okay, so next move then, get a line down the page. And over here I've got sin x plus 2 equals 0 and sin x equals minus 2. Okay, now what we're faced with here is, well, if you try to put that into the calculator, the calculator is going to come back to you and say that it's an error. Now what that means is there's no solutions from sin x when equal to minus 2. Now that makes perfect sense, because if you think about the curve sin x, the curve sin x only goes up to 1 and down to minus 1. It doesn't go up to 2 and it certainly doesn't go down to minus 2. So what we say there is that there are no solutions. So let's concentrate on where there are solutions, which will be over here. 4 sin x plus 3 is equal to 0. 4 sin x is equal to minus 3, and sin x equals minus 3 over 4. Okay, so I'm going to make it a positive result, and I'm going to look in tan and cos. Okay, we're on a radians question, so make sure that you're in radians mode. It's also a calculator question. Okay, x equals sine inverse 3/4. Okay, so that'll give me 0.85 radians, but I'm not in the all quadrant, so it's going to be 3.14 plus 0.85, so it's going to be 3.99 radians. And I'm also in the cosine quadrant, so it's going to be 6.28, take away 0.85, and that will be 5.43 radians. Final answer. Okay, let's try one more with a compound angle in it this time. So let's go for, I'm going to solve 2 sine 3x minus 40 is equal to 1, and I'm looking for solutions that lie between 0 and 360 degrees. Okay, my first move is to adjust the limits, so I'm going to take the limits and multiply them by 3 and then take away 40. So lower limit, multiply by 3, 0 times 3 is 0, take away 40 is minus 40. Upper limit 360 times 3 is 1080, take away 40 is 1040. And then I'm going to bring that 2 down, divide, so it's going to be sine 3x minus 40 is equal to 1/2. 3x minus 40 is equal to sine inverse 1/2. Okay, and at that point I'm putting down the cast diagram. Okay, and I'm going to be in the all quadrant and the sine quadrant. Okay, sine inverse 1/2, that's one of the exact values then, that's 30 degrees. I'm also in the sine quadrant, 180 take away 30, that's 150. I now need to exhaust every possible solution. Remember that the sine curve repeats after 360 degrees. So let's look 360 after 30, and that's 390, still within range. 150 plus 360, that's 510, still within range. 390 plus 360, so it's going to be 780, still within range. 510 plus 360, 870, still within range. 780 plus 360, and that's going to be 1140, and you can see that that's out with the upper limit, so I'm going to cross it out. I then need to add 40 onto each one of my solutions. So it's going to be 3x equals 30 plus 40 is 70, and then 150 plus 40, 190, 390 plus 40, 430, 510 plus 40, 550, 780 plus 40, 820, 870 plus 40, and that's 910, and finally divide all results by 3. Okay, so the first one then, to one decimal place, 23.3 degrees. Second one is going to be 63.3 degrees. Next one, 430 divided by 3, 143.3 degrees. Next one, 550 divided by 3, 183.3 degrees. And then 820 divided by 3, 273.3 degrees, and then finally the last one, which was 910 divided by 3, 303.3 degrees. Final answer.